The corner of filament, the corner of fun, the filament corner. Hey guys, this is the filament corner, the corner of filament, the corner of fun, with another video, and this is another basics or general video, and the topic for this video is bridging. And no, I don't mean a bridge you drive across. So, in 3D printing, you may hear the term bridging. People doing bridge tests and prints that require bridging. Now, if you think about a bridge you drive across, let's apply that basic idea here. You have 2 points. You need to get from one point to the other, so you just go across. Same idea for bridging. We have 2 points, or 2 walls. We want to get across them, so we just go across them. It sounds pretty crazy if you think about a big print and you just watch the nozzle go from here to here in midair. It reminds me of the cartoons of the construction workers just placing boards out, floating over nothing, going to the other point. And depending on the 3D printer, how it's set up, will depend on how well it can do that. That is why there are many bridging tests. And some of those bridging tests are quite long bridges. Now, bridging is from one point to another, and a lot of the time we either use supports with it or we use infill with it. Infill and supports are similar but not the same. Infill is inside an object. Supports are additional material that you normally remove after the print is finished. So, for example, the infill inside of this failed print is infill and not support material. I don't remove this after the print is done, but this may support as the print goes up. So the the building is a good example. These lower sections, this flat area, is supported by the infill. I don't remove that infill after the print is done. I'll leave it in there. It fills the innards, so to say. Support material you generally remove. And I do have a print on this table that is not only a functional print, it has bridging in the process that uses, well, I use support material for it. Many people would go, that short of a distance? But I go, I want to make sure that it's nice and not warped. Better safe than sorry. So here it is. Here's why why I use support material. This fan has to fit in this hole. Depending on your printer, the fan may not fit in the hole. And that is because this print utilizes bridging. So we move the fan. It prints like this. My palm is the build plate, and that is how it prints. This side is on the build plate. That means that the opening for the fan bridges right here. This area bridges. Now, normally in such a little area, you would let your part cooling fan do the bridging and not worry about putting in support for such a small area unless you knew that your part cooling fan couldn't properly provide enough cooling But I like to take the extra step, put a little bit of support material in here, just to make sure that my fan will properly fit in this gap. It's better to add a little bit of extra support and print it once than no support and having to print it twice. Work smarter, not harder. So, because I use supports, I know that this fan is going to fit in that gap. And if you've noticed, there's no support because I removed it after the print was done. So, I've shown you a functional print that uses bridging. We've talked about the basics of what bridging is, going from one point to another point, how it doesn't always have help in between those 2 points, but you can add help in the form of infill or supports, just to make sure that you have that properly bridged and not sagging and not properly creating a nice finish. Now, finally, you can actually do some creative things with bridging. So this was a functional part that happened to use bridging, but you can do some creative ones. They're not necessarily used for a function in the same sense as this, which is made to go on here and provide cooling, but this fella right here, the hairy line, is a prime example of creativity at work. All these individual hairs were bridges initially. There was a sacrificial wall that went around this print, and it bridged from the line to that wall. And after the print is done, you cut these hairs free. I've got plenty of pictures. I'll be sure to add them in.
Yeah, that's
editing.
what I was thinking.
And you remove that outer wall, and then you just either use a hairdryer or heat gun, or you use a hot water, and you shape these hairs backward. That's what we did with a heat gun. And now it has this extra tier of interesting. I show this to somebody, they're going to look at it, because yes, it's 3D printed, but look at all these individual
Little lines
lines
hairs,
and
yeah.
detail.
Mm-hmm.
And that's not something that you traditionally see with something 3D printed. But just taking that little extra step and adding a bridging component added a completely, what I consider a new tier to a model.
Yep.
See, I feel this is a very creative use of bridging because of what it does. Now, there are plenty of other models out there that use bridging. I'm just using this one because I've got it printed here. This is actually the third one that I've printed. I've got 2 more in the house. So yeah, good use of bridging as far as I'm concerned for the way that it looks after it's done. So to recap, I've told you the basic idea of bridging in 3D printing and what that term normally refers to. I've let you know that sometimes, such as bridging tests, the bridging will not have any help, but a lot of the time bridging can and will have help in the form of infill or supports. Sometimes it is better to support that bridging if you know that you need that bridging to not be warped and you are not certain your printer can pull that off. And finally, bridging is used in plenty of parts, functional and creative. So, with that said, I hope this has been a helpful video for y'all. This is just the basics. I'm just talking about the basics here. And I hope to see you watching another video.